Good evening. A few weeks ago at CPPCon, I gave a talk on object-oriented programming. There we go. I gave this talk, and the purpose of the talk was not to advocate object-oriented programming, but was instead to give it best practice. If you're going to use object-oriented programming, you should do it correctly. And one of the things that I said in the talk was that the cool kids don't advocate or even talk about object-oriented programming anymore. And I think this is true. I think if you look at the topics that you'll see at conferences, you're just not seeing a lot of object-oriented programming. So I think that's okay, because I want to advocate better ways of programming. I want to advocate doing things at compile time. I want to advocate functional style. So I'm not really advocating object-oriented programming. What I'm saying is, if you have a code base or if you're somehow locked into doing object-oriented programming, if you're committed to doing it, let's do it properly. You see, I want to be a cool kid too. All right. So afterwards, though, somebody came up and asked me, why don't the cool kids like object-oriented programming? And I suspect most of you could probably answer that question. I mean, why is it that's no way? But I was kind of struck because I didn't really have a good answer to give them. And that's really what this talk is about tonight. It's to answer the question, why don't the cool kids like object-oriented programming? And what I really want to say is that, first of all, it's because some problems don't really break down well into objects. And you can put an object-oriented API on just about anything, but that doesn't really mean that it's a natural fit to the problem you're trying to solve. But there are problems that are, in fact, polymorphism. And so let's talk about those for a second. This is something where object-oriented programming might be useful because it's a polymorphic situation. So what does polymorphic mean? It means that we're writing code that at the time we write the code, we don't know the actual types we're going to be using. That's true of object-oriented programming. It's also true of templates, right? So in the object-oriented situation, we're going to have a base class, and we're going to program to the API of that base class. If it's templates, then we have some idea of a concept, and we're going to program to the API of that concept. But in either case, we can look at it this way. Well, the coder doesn't know the actual types, but of course, at execution time, of course, the actual types have to be, that's what's being executed. So we need to know that. In the case of the object-oriented programming, what we're going to write to is not the actual types, but the base class. So at compile time, the compiler is generating code that's going to make calls against that abstract class. And what that means is that the compiler doesn't know any more than we do as a programmer. The compiler is also unable to know what the actual types will be used at runtime. And so it has to operate in this kind of abstract way of writing to an API. So what does the compiler know? And essentially what it knows is that the actual type, whatever it is derived from some base. In the template situation, we're in a little bit different situation, because in this case, we still are, as programmers, we still don't know what the actual type is going to be. We're writing something that can be instantiated in a number of ways. It's polymorphic. But the compiler is going to generate that code for us. And so at compile time, the compiler knows what the actual type is going to be. And so we've done this moving of the compiler from being as blind to what the actual types are as we are, to knowing what the actual types are. And so what that means is that the compiler knows the details of the types. And what that means is it can answer questions that we can't in an object-oriented way know. For example, it can know the actual size, or it can know any kind of optimizations that are possible because of the particular type. It knows everything about the type. And it may, in fact, know that it can inline functions, and that the inline functions might, in fact, do nothing at all. And that's very hard for object-oriented programming to optimize that away. So essentially what we've done is we've done this shift where we've moved the compiler from not knowing what we're trying to work with to knowing what we're trying to work with. And that unlocks all sorts of optimizations. And that is why the cool kids don't like object-oriented programming.